Welcome to another video on SIRJ Maths channel. Today we'll be looking at the topic, the sine rule. Now let us get into it. Now let us say we have triangle ABC, where, as we know, we have angle B over here is side B, angle C over here is side C, angle A over here is side A. Now there are 6 elements, 3 sides and 3 triangles and 3 angles. Now let us say if we know side A and we divide it by the sine of angle A, whatever ratio we get is the same as if we were to divide side B by the sine of angle B, and we'd also get the same ratio if we were to divide side C by the sine of angle C. Now what this gives us is a rule called the sine rule. Now we could also flip these and have sine A over A equals sine B over B, which equals the sine C over C. It is the same sine rule. Now, however, in working a triangle to find either a side or an angle, we are not going to use all 6 elements. Now, what we would basically use is, or what is involved, are really 4 elements, but you have to know 3 in order to find 1. Now let us say we have this triangle. So let us say we have triangle A, B, C. This side is 7 centimeters. This angle here is 49 degrees. This angle here is 32 degrees. And this side we don't know, neither do we know this side. Now we are told to find, say, length AC. So we are now told to find length AC. Okay, so this is AC that we want to find, which is little b. So you can put in a question mark. So little b is what we want to find. Now, it is possible for us to determine the magnitude of angle A right here. Now, we know that the sum of the angles, or the interior angles in a triangle, is 180 degrees. So we could find angle A. So angle A is 180 degrees minus the sum of 32 degrees and 49 degrees, which works out to be 180 degrees minus 9 and 2 is 11, 1 carry 1, 4 and 3 is 7, and 1 is 8. That's 81 degrees, which will work out to be about 99 degrees. And so we know that this triangle is not a right angle triangle. And if it is not a right angle triangle, we cannot use any of the trig ratios, neither can we use Pythagoras' theorem. So here we want to find this side, side B. Now, when we did the cos rule, we know that for you to use a cos rule, you have to know side, angle, side. So we must know 3 elements in order to find a 4th element. So we can use side, angle, side. That is, if we know 2 sides and an included angle, then we can find the length of the 3rd side. Or we would be given 3 sides, side, side, side. And this is when you use a cos rule. So let us examine. Can we use a cos rule here? The answer is no. Why? Because we only have 1 side. So for us to use a cos rule, we must know at least 2 sides, as we can see right here. So definitely you rule out the cos rule. So it means, therefore, we will have to use the sine rule. Okay, now we write down the elements that we basically have. We have angle B, so we use a capital letter to denote the angle. So angle B here equals 32 degrees. Now, if you notice, we want to find side B. Now, this is what you need to remember. If we want to find a side, it's a side B, we put a question mark, but for us to find side B, we must know angle B. And if we want to find angle B, we must know side B. And that's how the sine rule essentially works. So the sine rule essentially takes in 4 elements. Normally, you must know 3 elements for us to find the 4th element. So we want side B, we must know angle B. Now let us see another relationship that we have. Now here we have angle C. So angle C here equals 49 degrees and side C equals 7 centimeters. Now, the relationship that we are going to use, since I want side B, if you notice here, I have A over sine A equals B over sine B equals C over sine C. I can use any one of the, or any 2 relationships. So I can have A over sine A equals B over sine B. I can have A over sine A equals C over sine C. I can have B over sine B equals C over sine C. So what I am going to have is, I want to find the little b, I put little b over sine of angle B equals little c over sine of angle C. Now little b, I don't know it's alright now, little b over sine of angle B, which is 32 degrees. Now here we know that 32 degrees is actually in the first quadrant, equals little c, which is 7 centimeters, over the sine of 49 degrees. Now right here, these 2, b over sine 32 degrees equals 7 centimeters over sine 49. These are directly proportionate. And the short way of working out this is, we can simply cross multiply. So it's like b times the sine of 49 degrees, b sine 49 degrees, equals 7 centimeters times the sine of 32 degrees. Now remember, what I want is really b. Now b is being multiplied to sine 49 degrees. If I want, or since I want to find b, I am going to divide here by the sine of 49 degrees. So this gone. But whatever we do to one side of the equation must be done to the other side of the equation for it to remain balanced. So we divide also by the sine of 49 degrees. So b here equals, now I get my calculator and I multiply 7 centimeters times the sine of 32 degrees. But then I check on my calculator, sine of 32. So I have sine 32 degrees equals, now I am going to write it, as I said, correct to say 3 decimal places. So I have 0.5299, run it off to 3dp is 0.530. And then I am going to divide that by the sine of 49 degrees. That's sine 49 degrees equals, correct to 3 decimal places, is 0.755. So now side B equals, I have 7 times 0.530, I write equals, that's 3.71 divided by 0.755. So I've divided by 0.755 equals, and what I get here is 4.9, say 139.07285, but to 1 decimal place is 4.9 centimeters. Correct to 1 decimal place. So right here we would have found side B. Now, if we check right here, we know that this angle, so we can do a little check. This angle is 49 degrees. The side opposite to it is 7 centimeters. So clearly, the side that we are going to get for this angle, 32 degrees, must be less than the side that we get for 49 degrees. Because the smallest angle must basically lie opposite to the shortest side. Now here, example 2. Calculate the size of angle XYZ. Now, this is triangle XYZ, or ZXY, or ZYX. Now, the angle XYZ, you need to first identify which angle that is. Now, XYZ, you start at X, you go to Y, then you go to Z. So therefore, the angle basically lies at Y. That is in the middle. So if you're asked to find angle ABC, then always identify, or the angle would basically be in the middle right here. Now, let us see what we have. We have two sides and an angle. Now you might be tempted to say, okay, we can use a cos rule. But remember, for us to use a cos rule, yes, we need at least two sides, but the angle that we have must be between the two sides. Now, is this angle between the two sides? No. So even though we have a side and a side, we must have side, angle, side in that order. And so we don't have it in that order, so we cannot use a cos rule. So therefore, we are going to use a sine rule. So you don't have to know when to use a sine rule. You can know when to use a cos rule. Cos rule, side, angle, side. Two sides and an angle between, or three sides. And if those cannot work, then we know that it is a sine rule that we are going to use. And so if this is 46 degrees, which is angle X, over here is side X. So side X is 10 centimeters. Side Y is what I want to find. I can put a question mark. Over here is little y. So y here equals 12 centimeters. Now what we note, or what we know here, is that this side is longer than this side. So if this angle is 46 degrees, then clearly this angle must be greater than 46 degrees. Because the side and the correspond, or the angle opposite, has a certain relationship. So this side is longer than this side, so this angle must be bigger than this angle. So that gives you an idea as to what your answer is supposed to be like. So we write down, we have little x equals 10 centimeters. We have big X equals 46 degrees. What is it that we want to find? Big Y. So big Y, we don't know, which is the angle. So for us to use a sine rule, if I want angle Y, I must know small y, or common y. So little y here equals 12 centimeters. So using y over sine of angle y equals, so if I start with a side at the top, then over the other side, we must also have the side. So y over sine of y equals to x over the sine of angle x. Now remember, we could also have it as sine y over little y equals to sine of x over little x. And it's the same ratio that we would obtain. Now, put this now, we'll have sine of y, so it's sine of angle y, which I don't know, so I maintain the angle, over little y, which is 12 centimeters, equals sine of angle x, so it is sine of 46 degrees over 10 centimeters. Again, we could cross multiply right here. So I have 10 centimeters sine y, which is 10 centimeters times sine y, equals 12 centimeters times the sine of 46 degrees. Here I want to find sine y. So I'm going to divide this side by 10 centimeters. Whatever we do to one side of the equation must be done to the other side. I divide this by 10 centimeters. And so I take my calculator. I have sine y equals Now sine of 46 degrees. Sine 46. Remember, ensure that your calculator is on the correct mode. Ensure that it is on the degree mode, because if it is in radian, radian is another unit for angular measurement. Now we are looking at angular measurement here in degrees. So ensure that the calculator is on the degree mode. So the sine of 46 degrees, it's sine 46 equals 0.7193398. So rounding it off to 3 decimal places, it's 12 centimeters times 0.719. Divide that by 10. So it's now 12 times 0.719 equals, I get 8.628 divided by 10. Which works out to be, divide by 10, I'll get 0.8628. Or, to 3dp, it's 0.863. So that is sine y. Now, this is not the answer that we want, because the question sets out for us to find the angle. And the angle is y. Now, when you hear sine y, that's simple, is a ratio. So what we want is the sine of which angle that gives us 0.863. So to access the angle, we'll have to press the inverse function of sine. So then y equals sine inverse of 0.863. And so we access the sine inverse on our calculator and then type in 0.863, then equals, and what we get here is that y equals 59.655, which works out to be about 59.7 degrees, correct to 3 significant figures or 1 decimal place. So that is 3 significant figures. So the angle is 59.7 degrees right here. Now it is of note that, okay, 59.7 degrees is an angle that we can have here, but there's another angle that might be possible. Now 59.7 degrees is actually in the first quadrant. So let us go back to our unit circle. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and if you come right back here, it's 360 degrees. So this is quadrant 1, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, 59.7 degrees is actually found in quadrant 1. So this angle is, say, 59.7 degrees, which we realize here is found in quadrant 1. But there's another angle that is possible, which lies in quadrant 2, that can also have a ratio of 0.863. And that angle is supplementary to the 59.7 degrees. Now, when two angles are supplementary, it means that both of them add to give us 180 degrees. So what we could do is to take 59.7 from 180. So that's 180 degrees minus 59.7 degrees. And we are supposed to get, say, 100 and all right, let me get a calculator. We have 180 minus 59.7. We have 120.3 degrees. Now it is possible that 120.3 degrees will have the same ratio, but 120.3 is an obtuse angle that is found in the second quadrant here. So 120.3 degrees would be over this side. 120.3 is somewhere here. So all of this angle right here is 120.3. So let us see if it is possible that the angle could have been 120.3 degrees. Because if this is 59.7, and you could prove it, you could find sine of 120.3 and you actually get the 0.863. And so what is of note is that if you know, so the sine, let me erase this a little bit. If you know the sine of 100 degrees, which is in the second quadrant, you automatically know the sine of 80 degrees, which is in the first quadrant. Because 100 plus 80 degrees will give us 180 degrees. And so they will have the same ratio. So if you know the sine of 60 degrees in the first quadrant, you automatically know the sine of 120 degrees in the second quadrant. They are actually equal. So the sine of 60 degrees is, say, 0.866 or root 3 over 2. The sine of 120 degrees is also root 3 over 2 or 0.866 correct to 3 decimal places. Now, is it possible that the angle here could have been 120.3? Now, if this is 120.3 centimeters and this is 120.3 degrees and this is 46 degrees, then okay, 120.3 plus 46 will give us something like 160 something. So it is possible that that angle could have also been 120.3. But providing this is not drawn to scale, so whatever this is, this angle, it is possible that it could have been. But we are using the acute angle right here, so y here equals 59.7 degrees. Now when I say it is possible, it doesn't have to work out. It depends on the length of this side and the angle right here. But we're just looking at the possibility. So we are saying here, using the acute angle, acute, which is less than 90 degrees, that the acute angle here is 59.7 degrees, which is this angle right here. So we have found angle y. So we can write, therefore, angle xyz equals 59.7 degrees, correct to, say, 3 significant figures. Okay. Example 3. Calculate the length of QR below in triangle PQR. So this is triangle PQR. Now what do we know about triangle PQR? Here we have two angles. And here we have a side opposite to one of the angles. Again, cos rule cannot be used because we only have one side. Now, if we want to find the length of QR, which is little p, we don't know little p. But based on what we have been doing, if we want to find side P, we must know angle P. Can we find angle P? Yes, even though it is not given, because we know that the sum of the interior angles of a triangle add up to give us 180 degrees. So therefore, angle P would be 180 degrees minus 25 degrees plus 55 degrees, which works out to be 180 degrees minus 80 degrees. And this works out to be 100 degrees. So we now know that this is 100 degrees. So now we can set out to find our side. So we write little p equals, we don't know, but angle P is now 100 degrees. Now, when we look, we have angle Q. But do we know side Q? No. Can we use the relationship P over sine P equals Q over sine Q? No, we can't. Because in this case, we would have two unknowns. And the sine rule, consisting of 4 elements, we must know 3 elements. So we couldn't use P over sine P equals Q over sine Q. So here we have little r being equal to 16 centimeters. And angle R equals 55 degrees. So what we do know is that if angle R is 55 degrees and the side opposite to it is 16 centimeters, then if this is 100 degrees, then this side must be greater than 16 centimeters. So if by virtue of working the questionnaire you get something smaller than 16 centimeters, alarm bell is supposed to go off in your head, because that would be wrong. So we write little p over sine of big P equals little r over the sine of big R. And so we substitute our values. So we have little p here being we don't know little p, over sine of angle P, sine of 100 degrees, equals little r, which is 16 centimeters, over the sine of angle R, sine of 55 degrees. Again, we cross multiply. That's P times the sine of 55 degrees equals 16 centimeters times the sine of 100 degrees. So we divide this by the sine of 55 degrees. We divide also over here by the sine of 55 degrees. So little p equals 16 centimeters times the sine of 100 degrees. To 3dp is 0.985. And the sine of 55 degrees, sine of 55 degrees equals 0.819. So it's little p equals 16 times 0.985, which we get as 15.76 divided by 0.819. So it's 15.76 divided by 0.819. And what we get here is 19.2 centimeters, correct to 1 decimal place. So therefore, we can say length QR equals 19.2 centimeters, correct to 1 decimal place. So now, you have now known about the cos rule and the sine rule. These are two important rules if you are going to look at bearings. So next time, we may look at bearings. These are two fundamental rules that are needed to solve bearing questions. Continue to like my videos, subscribe, tell others about this channel, because it can help them.